Okay? And you can see the graph, that is actually true. It goes to negative pi over 3 and pi over 3. All right? So we're going to plug in these equations using the, going from 0 to pi over 3, and then we're going to double this area. So take it the whole area. Okay? So its area is equal to 0 to pi over 3. And this is double that area. So we're going to put a 2 inside there. Else. Radius. Okay. 1/2. 3 cosine theta squared minus 1 plus cosine theta squared d theta. Good. So now we're going to combine these two terms, and they're going to cancel out. So we have area is equal to 0 to pi over 3. So 3 squared is 9, and then cosine squared is obviously cosine squared, so 9 cosine squared theta minus, we're going to extend this out, so it's going to be cosine squared theta, so plus 2 cosine theta plus 1 d theta. So next, we are going to combine like terms. So it's going to be 8. So area is equal to pi over 3. So 8 cosine squared theta plus 2 cosine theta plus 1. All right. Okay, here we can see the equation again, and we distribute it in negative, and now we're going to do the double angle formula on cosine squared theta. So we have area is equal to 0 to pi over 3, 8 times 1/2 plus cosine 2 theta over 2 minus 2 cosine theta minus 1. D theta. Okay, so now we're going to combine, distribute the 8. So area is equal to 0 to pi over 3. That's going to be 4 plus 4 cosine 2 theta minus 2 cosine theta minus 1 d theta. Combining the 4 and the 1, that's going to give us 3. All right, I'm going to erase again, so pause the video and copy it down. All right, here you can see we integrated, and so we have the area is equal to 3 theta plus 4 sine 2 theta over 2 minus 2 sine theta from 0 to pi over 3. All right, and you can see where we integrated from before. So this is going to, we're going to substitute the pi over 3 into the thetas, and we're going to have 3 pi over 3 plus 4 sine 2 times pi over 3 over 2 minus 2 sine pi over 3 d theta. Alright. And now we have to subtract the 0. So it's going to be minus, I'm going to bring it down here. Minus 3 This simplifies to 2, obviously. So, all right, so this is 1 line. Okay. So we can see that this is just pi. Sine of 2 pi over 3 is root 3, of course, after multiplying by 2, of course. So this is going to be root 3. This is also going to be root 3, except negative, because of this. So there you go. 3 times 0 is just 0. 2 times 2, 0 is, obviously sine of 0 is 0. So 0. And the same thing, sine of 0 is 0. All right, so we're going to be left with the pi, the root 3, and the negative root 3. So area is equal to pi plus root 3 minus root 3. All right, and arithmetic tells us that. So we have area is equal to pi. All right, thank you, and I hope you learned something.
Hi, this is the third problem we're going to be doing. And this is the equation that we've been using. Area of a polar graph, a equals 1/2, integral b to a, r squared d theta. And our given is r equals rad sine theta, as you can see here. And our limits is from 0 to 2 pi over 3. So the first thing you're going to do is plug in r into the equation. And make sure you put your limits. And r right here would be rad sine theta squared d theta. Now since there's a rad inside the squared, they're going to cancel out. And so we're going to left with half integral of 0 to 2 pi over 3 sine theta d theta. And there you just basically finding the integral. You get a cosine theta. And the limits are from 0 to 2 pi over 3. So we're just going to bring this up here. It's going to be half cosine theta pi over 3. If you write that out, it's going to be cosine 2 pi over 3 minus cosine of 0. And from there, it's just solving it. Cosine 2 pi over 3 is 1/2. Cosine of 0 is -1, which is equal to +1, which is negative. And it's just 1/2 times 0 over 2, which gives you 0.4. That is how you do this problem.